Hey everyone, and welcome to my another tutorial on how to create this alien looking grass. Let's start by creating a grid. Let's increase the divisions because we're going to use a noise, attribute noise, to drive our point distribution that will scatter later on. Float, we'll call it F, and let's adjust it. I'm going to use the values that I have already used in my project to save time. You can use your own. Element size 1.29. Offset 88. Okay, let's scatter the points. Density attribute should be F. And force total count 9,262. Global seed 0.14. And no relax iterations. We don't need it. Okay, good. Now let's copy the lines to our points. Yeah, let's increase the length. 2.82. Yeah, now it's better. And yeah, guys, I'm not going to use backend instance because I'm going to deform the geometry after this node. And it's not a big issue because even after the resample node, we got 200,000 points, which is not a lot. And yeah, we're going to use curveview attribute. It basically creates a gradient attribute, which in our case, the lowest point will have the value of 0, and the top points will have the value of 1. Very cool. Then we'll create point VOP to deform these trails. And in it, I'm going to use anti-LS flow noise because it's really, really easy to make loop animations with this noise. It must be 3D, and we simply add this noise to our existing position. Boom. Everything is deformed, which is not what we need. Let's use our U attribute. We multiply our noise by the U attribute, and the low points are not deformed because their values are very close to 0. I think we need a ramp, right, to have a better control. Okay, nice. Let's promote all the parameters of the noise. Right click, Vex Swap options, create input parameters. We need less amplitude, obviously, like 0.189, and roughness 0.463. Okay, let's make it into a loop. We need to animate flow parameter for it. At the first frame it should be 0, alt left click, and at the 31st it should equal to 1. Alt left click again. So the 31st frame now is equal to the first frame. So the loop is created. Let's check this out. It is too fast. Obviously it's too fast. So to make it longer, we can use time shift. we can extend our loop to 60 frames just by dividing our current frame number by 2. And yeah, don't forget to set the timeline to 60. It lags a little, it's not a problem, I think. But it doesn't look like a loop because of the interpolation. So shift left click and select it and switch to linear interpolation. Now it must work. Yes, we got our infinite loop. Now goes the tricky part. Oh, actually before it, let's colorize our strands, our lines. And null strands out. So we need to separate our top points, to select only them. To do it, I'm gonna use for each method. If you know any other method, well, you can use it, but this one is, in my opinion, the most procedural, and it's always cool to know how to use it, how to work with loops. To do it, we need to create a thing called array. I'm gonna call it PTS. And this array will contain our primitive points. Prim points 0 and prim num. 0 because it's 0 input, this one, and prim num because, well, primitive points. We need to write the primitive attribute. Okay. So, to demonstrate how it works, how the array works, I'm gonna do this thing. And copy everything here. Let's go to the geometry spreadsheet and select primitives. You can already see the difference between a regular primitive integer attribute. Regular one has one value for each of the primitives. So it would be like 3, 6, 29, 157, and so on and so forth. But in this case, one primitive has many values. That's because of the array. And in our case, it has the primitive points, the points on the primitives. So we want to delete all the points except for the last. To do it, we can use for each loop. Int I semicolon and PTS, because it's the name of our array. It just creates this variable I that gets the value of each index of the array. So it gets the values of 0, 1, 2, 3, 4, 5, and so on and so forth in rotation. So how can we get the value, this value? Because we know that the length of the array is different on each primitives. First, well, let's actually calculate this length. I'm going to create a variable called length and use this function len. It gives us the length of the array. PTS. Oh yeah, I forgot. Okay, so for this primitive, the length of this array is 24 because it has 24 points. Yeah, the number of the last point is 23 because it starts from 0. And it varies depending on, I mean, the length varies depending on the primitive number. See, here it's, well, more than 24, obviously. And we need to separate, to subtract 1 because we want to know the last number, point number. Okay, but we got the length, it's not the last point number. To get it, we create another variable. I'll call it TPT, stands for the point. And to get it, we can type in PTS and length. Yeah, we can use actually anything, like can type in 0 here, and in this case this variable will equal to 0, 24, 48, 72. Can type in 2 and then it will equal to 2, 26, 50, so on. You got the idea. But the length is different on different primitives, so we use length. Yes, we got the number of the last point. Now let's do this. If I is not equal to TPT, last point of the array, we need to delete all the points. Remove point I. Oh yeah, I forgot the brackets. Okay, let's see what happened. Yes, we did it. These are the points. Cool. Let's create a null. PDS out. Yes, now let's work with the materials. Let's create, I'm gonna use Redshift, so RS material. Strands, and this one, PDS. Since we colorized our strands, let's bring the CD attribute. Color user data. And connect it to the base color. For PDS, they will be glowing, so I'm gonna use incandescent shader. Let's set it to 22 for now. Good. Oh yeah, and let's create another geometry container for our points. I forgot. Points out. Yes. Now our points are in a separate container. Okay, let's assign the materials. BTS. And this one should be strands. Yeah, and also we need to select that we need to render this as strands. So render object as strands, cylinder, scale 0.54, particles. Oh yeah, we don't need. We need to select this one. Redshift obj particles, render object as particles, and the scale should be 0.064. Okay, let's open the render view. RS light. Let's create lighting. Here you can select the right angle for you. Just the camera. Oh, yeah. Okay. Actually, let me use the values that I've already used. Just gonna be quicker. Okay, I adjusted the values for camera and both lights. You can see them here. So, let's adjust the bokeh. It's depth of field. Let's do it. Distance 2.3. COC radius 0.064. Oh yeah, good. And yeah, blade count, let's make it 8 or 6, whatever you like. I'll make it 8. And don't forget about bloom. Maybe this is too bright. Okay, it's fine. Okay guys, I hope you enjoyed the tutorial. Have a great day. Oh, and one more thing that you can do is you can make the points fade. So you can drive the emission intensity depending on how close the points are to the camera. Let's do it. We need to create just a point, and it should have the position of our camera. So we copy its position, copy parameter, paste relative reference. Okay, now let's create point wrangle, connect it like this, and first let's sample the position of our point, this point. Let's create a vector variable. Let's go pose point. We need the position, so we need P attribute, and we need the position of the point 0, because the number of this point is 0. Yes, we got it. Now let's create the attribute. Let's create it. Let's call it F attribute fade. F because it's a float attribute. So we need to fit the distance between the positions of the points and our camera position, which is this. Pause. And right now, if we leave it like this without fit, the farther the points are, the brighter they are. But we need to a different thing, an opposite thing. So I'm just gonna use these values 0.07 and 18 0. You can experiment with the values to get the look you want, but we've created the attribute. Let's bring it here. It's a scalar attribute, so rs scalar user data fade and connect it to the intensity. Okay. Yeah, it's better. You see in the background the points are not that bright. Let's see. Yeah, in comparison it's better. Maybe you need even the more bloom, something like this. Yeah, okay. That's all.